Hello, welcome to another episode on another interesting topic, mechanics, basically called vectors and mechanic. But we are picking the mechanic aspect away from the vectors, even though there will be some interconnections along the way. Then we have vectors, mechanics being basically break into two forms, which the episode will be dealing with the static aspect and the dynamic aspect. That is rest, object at rest, structures at rest, and the object in motion. So we are picking the first aspect. Let's look at some of the outline things that we are expected for these statics topics to cover. Basically, for students who are in the senior high schools, the areas that they need to cover for their examination. One, they are to distinguish between scalar and vector quantities, and resolution or resolve forces acting on objects that is at what a point. We can call them coplanar word forces. Then we also talk about how to find the resultant forces at a particular point that is at what rest or at equilibrium. Then we will also talk about moment of forces. Then determine coefficient of frictions between bodies. These are the outlines that they need to cover. So we'll be covering all these in the series, not in this episode. We are only going to maybe the first two or three in this episode. Then the subsequent ones will follow as is going to be in series. Now, we can also begin the topic without drawing some connection with the topic with everyday life. When I mention mechanics, I'm sure there are series of importance. We can call them the applications in everyday life. There are series of them. And I'll be talking about only two of those applications that we are going to be seeing. When I say mechanic, we can even think of mechanical engineering. So directly is on what? Engineering based on structural what? Of vehicles. So under transportation. Vehicles are being what? Manufactured based on the understanding of forces, understanding of motion, understanding of transfer of energy. All these things are being encamped, if I can say that way, are being enveloped together to generate our machines that we see on the road. So for transportation sake, trains, vehicle, motors are working based on mechanics, which mechanics talk about basically the forces, the energy, the transfer of heat, and all those things are being demonstrated. Even under the transportation, one basic importance of mechanics is also the construction of what? The seat belt or airbags. How seat belt, when you're in the car, when you are moving beyond the height, it hook you down. But when you are moving it yourself, so that you can extend the belt by yourself, it will go a long way. But when you sit down and the car it jets up, you can see that it has a particular length from which it can go. They are all under what? Thermodynamics. There are some principles of mechanics being applied in them. The brakes of a car, how the fluid is being transferred, is fluid dimension or fluid dynamics. How those things are applied so that when the brakes are pressed, there will be a transfer of fluid which pushes some forces to the brake band or the brake shoe for the car to stop. All these things are application of what? Mechanics. Then when it comes to household appliances, there are a series of, from the simple one you can see 6x, make use of principles of what? Mechanics. Then let's take it a lot higher. We can deal with refrigerators, which have transfer, also work on thermodynamics. So that transfer of fluid move from one compartment to another to keep your food always cool. You can see part of your fridge behind the back where we have the copper wires. Some portions are hot, some portions are cool. You can see there's a movement of fluid, forces being transferred to keep the material cool all the time. And one we can also think about will be the washing machine. It also works on the principle of what? Mechanics, forces. fluid movement, energy transfer. I guess you can think of so many everyday applications of what mechanics. Now, for us to begin, we are picking the first one, which is the difference between scalar and what vector quantities. When we talk of a scalar quantity, we are only talking about quantities that has only size or has only magnitude, that can only be measured, has no direction. So it is a quantity that is described completely by a word, its magnitude, the size of it, just how large, how small that object is. That is what a scalar quantity. So typical example is the speed, distance. We can only talk about distance. How 5 kilometers, 6 kilometers. We are only having the magnitude, masses, area, temperature, and what volume. All these things have their own SI unit. You can attach those units to it. Then when it comes to vector quantity, which basically the topic is going to sit on, it is a quantity which is completely described by both its magnitude and what direction. The direction can also be referred to as the bearing, the angle movement. That is the direction we are talking about. So when we talk of a vector quantity, a quantity which has both magnitude, size, and at the same time talk about what? A direction, a bearing on which it is moving. That is the vector quantity. All right. Typical examples is velocity, displacement, force, acceleration. But how we can express that in terms of a scalar quantity, we can say that a speed, which is a scalar quantity, of 15 meters per second, which is the unit of the speed, in the direction of 45 degree, 0.45, that is 3-figure bearing. This direction can also be as a speed of 15 meters per second on a bearing of 45 degree is what we call the velocity vector. So the velocity vector is given us in the first component should be the speed, the second component should be the bearing or the direction. So we can have a velocity or a speed of 30 meters per second on a bearing of 300. We will represent them in this form: 30 meters per second, 300 degrees. We also have a distance of 30 meters in a direction of 30 degrees, or a distance of 30 meters on a bearing of 30 degrees. It's also called the displacement vector. So a displacement is also a vector which has the dimension as, when you see this distance, then the angle give you displacement. Then we have applied force. So a force of 60 Newton in the direction of 300 degree is also the force vector. So a force vector or a force is also an example of what? A vector, a quantity that has both magnitude, size, and what? Direction. So this is what we can see, the vector component of what? A force. If you can see the outline we are looking for, after knowing all this, we are knowing them because we want to talk about force. We are only going to narrow all these things towards forces. Maybe a little bit of acceleration along the way. So forces is a vector which can be of a force measurement and the direction or the bearing. Okay, that is clear. So now let's narrow everything to force and define what forces are, the various components or types of forces, how we can represent forces, and come back to how we can resolve forces. All right, to continue with that, forces is just a physical quantity that can be brought into equilibrium with gravity. When you are able to push an object, if the object moved, then it means that the external force you are applying is bigger than what? The force, which is the weight of the body. So when your force that you are applying is equal to that of the object, then the body is equilibrium, is at rest. You are saying that it is a physical quantity that can be brought into equilibrium with what? Gravity. Meaning gravity is the force, the weight that is exerting on the body. So your force can be brought to equilibrium by that force, which is the force of gravity. Or better still, we can say is a push or what? A pull. When you push or you pull, you are also exerting what? A force. All right. So if a body is in equilibrium, then it means that the force you are applying is equal to the weight. That is, the weight of the body is just the force at which the earth is what? Absorbing or exerting the attracting the object. So the weight of the body itself, that is there. Then when your force is equal to that, then the body is at rest, meaning it has what? Equilibrium. It is also referred to as push or a pull, I mentioned. So in mechanics, we encounter various type of forces. The components which we can list, not all, this is some of the components, is a pull or a push or a weight, normal reaction, tension, and friction. I think we also have to call thrust. THRUST is also a form of forces which is applied in what do you call it, in mechanics. All right, so we are going to pick these ones and describe them, since we need their diagrammatic representation. The first one is a push or a pull, or both combined together. These are forces which act on a body at the point or point where they are applied. So they will just be acted onto a point where they are applied. We can see when they are doing competition for Ghana most strongest competition, some members are able to pull a car by attaching a string on the car onto their body, then they move. You can see that as they are moving forward, they are pulling the object, or they can go behind the object and exert forces, so the force will move in the direction that they are pushing it. That is an example. So you can see when you push, you are exerting the force towards the body. You are applying the force at a point towards the body. Then when you are pulling, it means you are also applying the force at a point, but this is what? Away from the body. So that is, we are pulling, more or less like a tension. Then we have a weight, which is the force with which earth attracts the body. The force at which the earth is what? Attracting the body is the weight of the body. It is always it always acts downward to the center of gravity of the body. So it is always down, meaning it's exerting. As I am standing in here, I'm exerting a particular force on the ground. That is my weight. So the weight at which I'm exerting the force on the ground is what we are calling what? The weight. That's why if I stand at a point, maybe the ground is a little bit soft, my weight will cause my feet to be embedded. But if somebody is weight that is not up to mine, when they stand, they might not be able to exert forces that will let the leg be embedded. I think those things show the weight of the body, the amount of matter contained in a material. That is the weight. So if the body is on a horizontal plane or a horizontal surface, the weight is acting downward. But if the weight is also exerted on an inclined plane, this is an inclined plane, this is the surface. So this is an inclined surface or inclined plane. It is also going to be exerted at the center of gravity towards, downwards. So this is a representation. You'll be using more of this when the lesson progresses forward. Then number 3 is the normal reaction, which is the force the surface exerts on the body in direction at right angle with the surface in contact. So you can see that as the body is exerting a particular force on the ground is also exerting some forces against the object. So the weight is moving downward, then the normal reaction is moving upward. So we can say it is the force, the surface. So when it is here, a weight will be exerting it downward, then the force that the object, the surface will exert, because the body is on top, so it cannot exert downward. It might exert the force upward. So upward movement, downward movement for weight upward for what? Normal reaction. On the body in direction at right angle. It is always at right angle of what? With the surface in contact. Let's see its representation. So the normal reaction is also represented on both the horizontal plane or horizontal surface and an inclined surface. You can see that it is being defined as the force that the earth is exerting on the object upward, always in right angle. So as the earth is exerting the force upward, the body is also exerting a force, which is the force at which the earth is absorbing it. If we come to the incline, you can see that this is at the right angle, but this is not, but because this is moving the force downward. So the weight is downward, not directly in line with this. We can get the point that directly in line with this will not be the same as the one which is moving this way. So this one is the weight, and this is what? The normal reaction. When you move forward, we begin to extend this line and find some formulas that can be used in calculating friction. But let's see number 4, tension. It is the force or forces in springs. When we use spring, anything that is extendable, we use spring, use strings, ropes. When we use those things, we are exerting a particular kind of force, which is called tension or tensional force. So, for example, when we are hanging a body to a surface, you can say that this is the, let's take this as a rope. When a rope is applied, the object will be exerting a particular force downward, which is the weight. Then the force which is moving upward by the rope is the tension. All right. When we use a spring also, similar is applied. Diagram drawn a little bit bigger. You can see that the spring will be exerting object a force on the body upward towards the surface. Then the weight is also moving what? Downward. That is an example of what? Tension. Then the number 5, which is not the last anyway, is friction. And friction is a force which acts on a body in contact with a rough surface. Rough surfaces, when we are walking, you can see that when on a normal day, when you are walking, your walking is possible because of friction. There is a particular force acting between the sole of your feet and that of the ground. So as you project to move forward, there is a particular force holding you backwards. That is the friction. Now, when we have a rainy season where the ground is a little bit slippery, let's just call that ground what? Smooth. You can see that your movement is not as easy as on a rough ground, because as you are moving, the friction is very small, or we can call it frictionless. There is no friction, there is no movement force in the opposite direction of your force. So we can see that you are not having balance. Your balance is what? Taking off. So we can see a friction we are discussing here is basically on rough surfaces. When the surface is smooth, then there is no friction, or the friction becomes very negligible, very small. Just like when a tiled ground is having water or oil on the surface, you can see how difficult it will be for you to walk, because your movement is the force you are applying. Then there should be a force holding you back, preventing you from walking. That is the friction. But here there is no force preventing you. Therefore, your movement becomes what? Destabilized. All right. Since this becomes the last, you can see the diagram. As the force is applied to the object, then the friction is also moving in the opposite direction to prevent this from what? Moving. So when the force is applied and the friction is the same, the body remains as what? Rest. But the moment applied force exceed the force of friction, then the body what? Moved. Now, the next episode, since the episode is getting longer, the next episode we are going to pick the various type of friction. We have 2 type of friction: dynamic and what? Static, or limiting friction. Limiting is also like what? The dynamic, the static friction. We will take that one and try to discuss what the coefficient of friction is. Remember the outline we outlined. we need to discuss the coefficient of what? Friction before we think of what? The representation of what? Forces. Don't forget, this is just the introduction, the concept. The episode 2 will continue from here. Come back to the episode, like, share, comment, and subscribe.